So today, first of all, I want to talk about domain and range. So you guys all heard about this before, right? So domain and range. So when you hear domain, so in simple terms, so there's of course more formal definition of them, but domain is, I would say, all allowed values of x, and range is the corresponding y values. So we can think of it as allowed values of y as well. So the range is allowed values of y. I think you know this already. So when you have a function y equals to x squared, so I'm keep using this as an example. So you get a parabola like this one. So I want you to think about the allowed values of x here, or allowed values of x. So think about the domain for this one and range for this one. Okay, so you can type your answers on the chat box, or you can draw if you have the drawing capability. I think during the update they got rid of the drawing function from here, so we'll have to wait a little bit for that function to come back. Yeah, so could you guys type? Of course you won't be able to see this chat box, but you guys can see everyone else's response. So I want you to think about the allowed values of x for this function and allowed values for y for this function here. So you have to say something like x is greater than 1 or less than 1, something like that, you know? I'm waiting for responses. Chris? Hello? Why is everyone so quiet? All right, Philip, do you have any idea about the... Okay, that's fine. Ishita, do you know? Or Elizabeth? Okay. Okay, just give me a second. Yeah, Elizabeth, because you can't hear us, I'm gonna use this phone to so you can hear us. Okay, so hear me talking. All right. Yeah. So just yeah, we're gonna use the phone. All right. So we're looking for the value of the domain and range for this one right here. You can see that like x can be anything. So the answer is x can be between infinity and negative infinity. So this is the domain. Because there is no restriction on what x can be. So x can be anything that you can just plug in anything into x here. So, you know, this just goes on forever. It goes up and up forever. So you can choose any value. You can choose like 3. You can even choose like 10,000. You see, then you get any value you want. So x can be anything. So we sometimes write the domain like this. Or sometimes we write the domain like this. X is an element of, so this is it looks like this. So it looks a bit like E, but it's curly, okay? So this means element of. Element of, okay? we say real number, all real numbers. So we write R, but we put another line next to it, so it looks like a big capital R. Okay. So that's all real. So all real number means negative infinity to infinity. So that's the domain. All right. Now we can talk about the range as well. Okay, just hold on. So what happened? So range. So range is the allowed values of y. So it means you can see that the y doesn't actually exist in the negative side. It's only existing in the positive side, right? So it can be as low as 0, and it goes up to infinity, doesn't it? So the value for y, the range is given as y is greater than 0, but it can also equal to 0. So have a look at this point right here. So it's actually touching 0 there, right? So that's equal to 0. So we can also write this as y is an element of all positive real number. So that's all positive real number. But that doesn't include 0, does it? So we put U, so this means union. So I'm introducing a lot of notation. So U means union. So you can think of that as plus, okay? Sometimes that's read as or, okay? So it's a union, and we put a curly bracket here, and we put 0 there. So what that means is y, allowed values for y, is all the positive real number. So that's including like 0.000001 union. So you want to also include 0. So that's how you write the range. Okay. So that's domain and range for this function right here. Sometimes people in a textbook, in your year 11 BSS textbook, you will see some notation like this: f, and then colon, r to r, and you have comma there, and then the function f of x equals to x squared. So this is the formal way of defining this function right here. So this is a function such that, so you can read this column as such that domain is real number, and you can read this arrow as maps onto. So you can read this symbol here as maps onto. Okay, and that's also real number. So you may think that this is a domain and this is range, but this is domain and this is called codomain. So this is called codomain. So this knowledge is very, very important. But codomain has really nothing to do with the domain. Codomain is something that is bigger than the range. So codomain includes the range. Okay, so codomain includes the range. So what it means, so you can see that if we want to define this function, we can, because we see that domain is all real number, so we can actually write, so we could write function and domain is all real number, and this maps onto real positive number union 0, and then comma function f of x is equal to x squared. So we could do that, you know, instead of this. But you can see that we have to be very strict about the domain, but we don't have to be so strict about the codomain. As long as the codomain includes the range, it's fine. So usually, because even though this one doesn't include the negative, we just say, when we write the function, we just include the codomain, which is much bigger than the range. So it's very convenient, you know. So I'm going to give you another example. Let's think about y equals to root of x. So this one looks like this. Okay. So this one here, the domain is, so I'm going to write domain. So you can see that x does not exist on the negative side. X has to be either 0. So you can see that inside of the root, you can never plug in a negative number. Okay, so that's why it does not exist on the negative side. But x can be 0 because root of 0 exists. So root of 0 is 0. Okay, what's going on to Philip? Philip, are you all right? Hello, Philip? Yeah, how come you're like logging out and logging in? Computer died. Are you okay now? Okay, cool. Yeah, all right. I'll just continue. So in this case, so root of x, the domain, you cannot have anything less than 0. So domain has to start from 0 and it extends out to infinity. Do you understand that? So that's the domain. It includes 0 as well. So we put an equal sign there. Okay. So this is the domain, and the range is, so if you look at the equation, the graph right here, it can be as low as 0, and it's keep on increasing. So it extends to infinity as well. So it's very similar. It's so this is the range. Okay, but we can write this function as f such that domain, of course, domain has to be all positive. So we have to be quite strict about the domain, okay? So domain is all positive number, union 0, so include 0, maps onto the codomain. And you can be quite liberal about the codomain, okay? It doesn't have to be like this one. You can just write all real number. Okay, so we don't have to be so strict about the codomain. As long as this includes the range, it's fine. All right, and of course, all real number includes everything. Comma, and then you put f of x equals to root of x. So this is the formal way of writing this function right here. Okay, so that's the formal. So we're learning the formal way of doing it. Now, we're going to consider an example. Let's have a look at this one. Y equals to x squared plus 1. So let's think about that one. So we learned about graph translation. So this is original is x squared, and if you plus 1 to it, does it move up or down or right or left? I want you to answer that question now on the chat box. I'll just wait for your responses. Okay, I got one response. Chris saying left. Anyone else? Philip? Lizzie, do you know? Left. Philip says I don't know. Okay, so this one is going up by 1. So we covered that in one of the previous lessons. So I recommend you guys to go back to it if you are still struggling with graph translation. Okay, so if you have f of just briefly, if you have x original thing plus 1, that's moving up by 1. If you have f of x minus 1, then that's moving down. If you have f of x plus 1 inside, then it's moving to the left. And if it's f of x minus 1, then it's moving to the right. So if the original function is equal to x squared, this one right here would look like this. F of because it is the original is f of x is x squared, so this will be x squared plus 1. So that's moving up. That's this one right here. And f of x is x squared, so x squared minus 1 will be moving down. And this one here is f of x plus 1 inside. So that's replacing x right here. So that's equal to x plus 1 all squared. And this is x minus 1 all squared. Okay, so if we draw all of them on the set of axes, you get this one here would be this. This one would be like sort of like this. So that's 1. This is minus 1. And this one right here is moving to the left. So that's actually negative 1 here. So it'll be sort of like this. And the other one should be sort of like this. Okay. So you get all of these things. So now we are looking at this one, this particular one right here. So I'm going to use blue pen now. So this one is x squared plus 1, isn't it? X squared plus 1. So that's moving up by 1. So this point right here is 1. So what do you think is the domain and range? I want you to think about that and think about, write your responses here on the chat box. So I want you to think about that very, very carefully. So domain is the allowed x values. It's actually, if you think about it, it's not too difficult, okay? So you can write your responses on the chat box. Ishita, can you still not see the screen? Okay, so I received the message like at 7:06. Okay, it's all good then. So, what do you think is the domain, guys, for this one? Okay, so that's actually, so Chris said it's 1 to infinity. Is that what you meant? So what you meant is like 1 and y infinity. Well done. So 1 y infinity, that's actually the range, isn't it? But the thing is that the range, so Chris tried, I think she got range. So range is 1 and it includes 1, okay, because that point right there is 1, and it it can take, if you take all these values here, it goes up to infinity, doesn't it? So this one goes up to infinity. So every time you have an infinity, you shouldn't put an equal sign there. You should always have just inequality, okay, without equal sign. So you have to think about the domain as well. So what do you think is the domain? Anyone? Let's have a look. You can tell me the answer verbally instead of typing it. Lizzie, would you be able to tell me what the domain is for this one? Don't know? The domain is the allowed value of x. So look at this graph. Is there any value of x that this is not allowed, that x is not allowed to be? So x can be anything from this one. You can see, think about this thing here. This is the original graph, original function. But is there any number that x cannot be? The answer is none. So x has to be between infinity to infinity. You can't negative infinity to infinity, okay? So that's the domain for this one. And as you can see, if you look at this whole graph, I'm going to redraw this. Oh, oops. Sorry, it's too sensitive. All right, so if you look at this graph, this parabola, you can see that, hold on. You can see that this extends to infinity. And if you take all these values, so like that's x value here, this point right here, that's x value right here, and that's that point there comes down, and that's x value there. So this one goes out to infinity and negative infinity. So x can be anything. So you can see it stretches horizontally from infinity to negative infinity, you can see. But vertically, this one is only going from 1 to infinity, right? You guys should be able to see that, okay? So we're going to try another example. I'm going to draw some random graph. So it's a bit hard, I know. So this one goes down to infinity, this one goes up to infinity, okay? But keep going to the right and keep going to the left. So I want you to think about the domain and also the range. So it's one of the difficult topics in maths, I know, but it's very, very important. You guys can also enable your videos. That would be more fun. Maybe boys can show themselves first, Chris and Philip. If you guys can just click on the video button at the bottom right here. Okay, so it's around here, okay? If you don't want to, that's fine, okay? But maybe from next lesson, I'll make it maybe compulsory, I don't know. All right. All right, so Philip, okay, so you guys don't have webcam. All right, so domain and range for this one again. The domain here is negative infinity. So you can see that this one is keep going to the left. It's also keep going to the right, isn't it? So this is negative infinity to infinity. And if you think about the y values, it's going to keep going up to infinity, and it's keep going down to negative infinity. So and it traces all the values of real number up to infinity, and there is this down and up moment here, but that doesn't affect anything about the range. So range, it passes through it, it takes care of, it goes from negative infinity to infinity. So that's the answer for that one, okay? So I want you to type your understanding level here. So from 1 to 5, okay? I want you to describe your understanding level of domain and range. So 1 is extremely confusing. I would say 5, extremely easy. 3, somehow I understand. Can you type your responses? Chris, 2, okay? Okay. Ishita, 1.5, okay, cool. So I guess this is a difficult topic for some of you. So anyway, so now we're gonna move on to a different topic now. So that's just a brief introduction to domain and range, and it's very, very important for year 11 and year 12 mathematics, okay? So I'm gonna now talk about functions and relations. So difference between a function and relation. So every function is a relation, but not all relation is a function, okay? So within a relation, if I draw a Venn diagram, so this is a relation. Within relations, you have functions, okay? So all functions are relations, but not all relations are functions. So I'll give you an example. So what is a function? So you can do a very simple test. So you can do what is called a vertical line test. So you drop a vertical line, and if it passes through, I'm going to type it here maybe. maybe like this. So drop vertical lines, and if it passes through just one point everywhere, then it is. Oops, it's not moving. Made a mistake. But anyway, so if you drop vertical lines and if it passes through just one point everywhere, then it's a function. Okay, so that's for this one here. So let's think about this. If I have some graph like that, and I drop vertical lines. So I drop vertical line here, and it seems like it's just going through one point. And vertical line there is just going through that one point there. Vertical line here, and it's going through one point. Vertical line, and it goes through one point. So everywhere I put a vertical line, it's going through one point. So that means this is a function, okay? But relation is something, of course, every function is a relation, but something that is not a function, I'll show you. So let's take a look at this one. Maybe you've seen something like this. And let's drop a vertical line through it. And it's going through this and this, right? So this is not a function. It's just a relation, okay? So that's how you tell the difference between functions and relations, okay? So that's just a brief introduction. And we're going to see many functions and relations today. We're going to see linear function, quadratic function, cubic function, quartic function, circle, hyperbola, etc., okay? Now I'm going to introduce something called even function. So we're going to go through, we're going to just talk about functions now. So there are three types of functions. One called even function. Another one is odd function, something that is neither. So an even function is, I would say, symmetrical with respect to, so that's WRT, with respect to the y-axis. So y-axis. So what's an example of that? Definitely this one. So you can see that when you rotate this side, this right hand side onto the left hand side, this side coincides with this part here, right? So this is symmetrical with respect to the y-axis. Something like this is an even function. There's something called odd function. I'll show you an example. Give you an example. So this is y equals to x to the power of 3, and this is known as odd function. As you know, this one is y is equal to x squared, right? So this is y is equal to x squared, and that's even, and this is odd, right? But as these numbers indicate, so this is an even function, this is an odd function. So an odd function has this property. So you take one side, the right hand side, and then reflect it onto the left hand side. Then what you're going to get is, so this part here is going to go there. So you fold it like this once, okay, and then you fold it vertically like this. If you can you guys still see me through the webcam? So I'm using gesture, you know. So you reflect the right hand side onto the left hand side, and this reflected bit, if that's also reflected against the x-axis as well, then that would coincide with this bit here. So if it has that sort of property, then that's called odd function, okay? So I would say, how do I describe it? I'm going to write here, fold against y-axis and x-axis, they coincide, okay? They coincide. That's an odd function. You know, anything that's not even or odd is just neither. It's just the regular function, which is not even, not odd. So an example of that could be, you know, I gave you something like that. You know, this one is, if you fold this one to this side, it will sort of look, I'm going to use maybe a different color. So if I reflect this bit onto the other side, it'll sort of look kind of like that, right? So that's reflected. But if you reflect this against the x-axis again, then it will look really, hold on, just choosing a different color. Yeah, then this will become kind of like this, and like that. Of course, that doesn't match the black, so that's not even, not odd. All right, for an even function, it has to satisfy. How do you check if something is even function? So this is for even. If you put negative x into the x, and if it turns out to be the same as f of x, so if it satisfies this equation, it's an even function. What's an odd function? If you put negative x into the x, and it turns out to be negative of f of x, then that's an odd function. So we're gonna try that for this one right here. So f of x is equal to x squared. So we're going to start with this one here. So f of a negative x. That's equal to, you put negative x into the x right here. So of course it's a square of the negative x now. Okay. Of course, negative square, negative cancels out. So the only thing that remains is, if you square this, it's just going to be x squared. But x squared is the same as the original function. So you can see that f of negative x and f of x, they are the same. So it's actually satisfying this one right here, right? So that's how we know that this one is an even function. We're going to now try odd functions. So we know that f of x is equal to x cubed is an example of an odd function. Is that right? So we're going to try, we're going to plug in, we're going to start with this one. So f of a negative x, this is equal to negative of x to the power of 3. But if you do negative to the power of 3, then the negative survives. So it's going to be negative x to the power of 3, which is actually negative of x to the power of 3 is the x to the power of 3 is the original function. So that's, we can replace that as f of x, and definitely can see that f of this is satisfying. So you can see that this one here is equal to this one, which is satisfying this one, right? So I want you guys to maybe try this example. So I'm going to maybe give you function f of x is equal to x squared over 1 plus x squared. So I want you to figure out if it's an even function or odd function, or neither. Okay, the first step to do that is start with f of negative x. So compute f of negative x. Okay, and that would equal to, you plug in negative x into x, plug in negative x into x. Okay, so what's this? Square plus negative x squared, right? So you can think about it for a minute, and you can tell me if it's even or odd or neither. I think someone has already answered. Nope. So you can choose one of those. You can give your answer verbally. Maybe that's quicker. So Chris, do you think it's even or odd or neither? Ishita? Lizzie? Philip? Did you say even? Okay, so I'm getting responses. So yeah, Chris said even, Philip even, all right. Let's have a look. So the answer is even, because the negative sign disappears. You can see that this one is gone like this. Negative sign is gone, and it's 1 plus x squared, which is actually the same as the original function, isn't it? So that is satisfying this quality right here. So I'm going to actually show you what this one actually looks like. So this is actually a very, very complicated function. So I'm going to go to this graphing calculator. So this is a x squared over 1 plus x squared. And take a look at this. It's like that. And let me ask you this: is this symmetrical against the y-axis? The answer is obviously yes. So that's why this is an even function. Okay, we're going to try another one. So, just by checking if it's even function or odd function, you can actually sort of predict what, if you know how to graph one side of the axes, then you can plot the other side as well. So let's have a look at another example. So f of x is equal to, let's say, x to the power of 5 minus x to the power of 3 plus x to the power of 1. So I would like to know if this is even or odd or neither. So basically, all this looks like it's odd, odd, odd. So it's power of 1 here. So, our instinct tells us it's actually odd function. True. Well, let's just try this. So f of a negative x, and this will be negative x to the power of 5 minus negative x to the power of 3 plus negative x, right? So if you actually expand this one out, the negative sign will have to survive because it's odd. And this negative sign survives, but there's another negative, so it's a plus. X to the power of 3, and plus and minus is minus x. So we can actually pull out the negative sign from all of this. So you can pull out negative sign. And this becomes x to the power of 5. And because it's positive, it has to be negative, because negative is positive, right? X to the power of 3. And this is a negative x here, so it's pull that out, then you get plus. Okay? So we can see that this here is the same as the original function, so we can just simply put minus sign there and f of x like this. Okay? So that means this is satisfying the quality of odd function, isn't it? So that turns out to be the same as negative of the original function, like this one here. So we can go on and plot this as well. So I'm going to go x to the power of 5 minus x to the power of 3 was plus x. So have a look at that. So this is, I think, satisfying it looks really weird, but it definitely looks like when you fold this part against the y-axis, then you get sort of like this, and if you fold that against the x-axis, you get exactly this one, right? So that's an example of odd function. Now we're going to move on to another topic, which is a piecewise function, which is a bit confusing. Okay. Now what time is it, by the way? 7:45. So we'll do theory, the concepts, for another 15 minutes, and then we'll just do questions and questions upon questions. All right. So there's something called piecewise function. Piecewise function. So a function could be defined with a curly bracket like this, and I can write x squared, and the condition is with a comma, x is less than 0, x is greater equal 0. So what that means is that the function is just going to be x when x is less than 0, and the function is going to behave as if it's x squared when x is greater than or equal to 0. Okay, so what does that look like? So in the coordinate, in the axes, the set of axes, this part I'm gonna do this in blue. So this one I'm in red. So this one is x is less than 0, and this one's blue, x squared greater or equal to 0. So the blue region is when x is greater or equal to 0. So that means it's this positive side there. And the negative is right here when x is less than 0. But the 0 is included in the blue region, okay? Like this. So when x is on one of those values, it's going to behave like x squared. So we know what x squared looks like. We know that x squared looks like this. But we cannot draw that on the negative side because x squared is only working for the positive numbers, values of x. And now, for negative x values, the x it has to behave like y equals to x. So what that means is we know that y equals x looks like a straight line. So it's going to be a straight line like this. Oh, sorry, that has to be in red. So it's a straight line like this, but we cannot continue drawing it on the positive side. So eventually the graph will look like this and just this. Okay, so that's the end of this graph here. So this is a piecewise function, so it's defined in pieces. So that piece there and that piece there. All right, so that's an example of piecewise function. I just want you to know that when we do these questions, you can see that sketch the graph of the following function. So f of x is this bit if x is greater or equal to -2, but it's going to be this function if x is less than -2. So it's defined piecewisely. And you have to also mention the range as well. So state the range. This is a domain right here. Okay, so we're going to come back to this question later. All right. We're going to now move on to different kinds of graphs. So we still have like 10 minutes to talk about concepts. So I think you guys all know linear function. So y equals to mx plus c. So that's a straight line with a gradient of m and the y-intercept of c, right? So that's a linear function. We also talked about, we didn't really talk about the linear function because I just assumed that you guys know them already. So quadratic function, we talked about this in our second lesson. So there are 3 forms of quadratic equation. Bx plus c, y equals to a, x minus alpha, x minus beta, y equals to a, x minus h squared, plus k. So these are the 3 forms of quadratic equation. And when you have the axes, you get some parabola like that, and this is like the alpha, this is beta, and this is the vertex, and this is the y-intercept. So you need all of these information to be able to plot the quadratic function. The basic form of cubic, so cubic is power of 3. So this one's power of 1, this is power of 2, this is the power of 3. So I'll introduce the 3. The general form, of course, is a x to the power of 3, bx squared, cx plus d, as you expected. Another form is the factorized form, which looks very similar to this one, which is a x minus alpha, x minus beta, x minus gamma. Okay, and there are a few other forms as well, but maybe oh yeah, I think just one other form, x minus h to the power of 3 plus k. All right, so you can have that or that or that, okay? So generally, it looks like this, so with 3 x-intercepts, but it may not have any, it may just have 2 intercepts. So this one is when it has, 3, 1, 2, 3 intercepts. I can draw another case where it has just 2 intercepts. So that's 1, that's 2. So it can also have just 1 intercept, like for example, right here. So it can go sort of like this. So that's still cubic though. Hold on. Yeah. So these are the 3 different shapes that a cubic graph can take. So normally this one right here, this one here is like this one here. So it's sort of flat. It doesn't go, this one is going up, down, up, but this is only going up. Okay, so that only happens when you have this form. Okay, and we talked about also like various kinds of polynomials, which is, when you have polynomial. So if you're confused about polynomials today, I recommend you to go back to lecture 3 and 4. So we talked about how you can graph like, x minus 1 square, x plus 1, like x minus 3, stuff like that, when we talked about polynomials in lecture 2 and 3. So you should also know how to plot something like that. But these two, this one is sort of new this time, but you can actually, so this cubic function and quadratic function is actually sort of is a topic that is overlapped with the topic of polynomials, because this is a polynomial and that's also a polynomial, okay? And I introduced to you today the y equals to root of x function, So that was like this, okay? And some time ago, I think we talked about exponential function, y equals to a to the power of x. So that's a function that looks like this, and it goes through 1. And there's also a hyperbolic function, which is y equals to 1 over x. It's like this, and like that, and it doesn't touch this vertical line, and it doesn't touch the horizontal. So these 2 lines are called asymptotes. I'm going to write here asymptotes. So asymptotes are lines that the curve never touches. So that's the basic shape of the hyperbola. So this is known as hyperbola. Hyperbola. And also we're going to talk about equation of circle. So x squared plus y squared equals to r squared. So that will give you a circle with radius of r. Okay, so for example, if this value is changed to, let's say, 3 square, which is 9, then the radius here would be 3. So this will touch here 3, minus 3, 3, and minus 3. Okay, so these are, I'm just basically introducing them. I don't expect you to know like how we get this graph from this one here, how you get this graph from this one here. So I don't expect you to know all of them at this stage. But I want you to notice something here, that this is a function. This is a function. These are all functions except this one right here. Okay, so this is a relation, because if we put a vertical line through, okay, so if we put a vertical line through, it goes through 2 points, right? So, but here, if you put vertical line through, it's only going through 1 point, right? So that's a function, that's a function, that's also a function, okay? Now, it's time to have some fun. I think we should try some questions now. We're going to start on this section here. You guys all received this thing by email, right? Or for some people, I printed this one out for you. So I'm going to copy this and paste it onto oops, why is it not showing up? Okay, there you go. All right. Let's have a look at the first question here. So it's very, very simple. So it says f of x is equal to 4 plus 5x squared. And it's asking what is f over 2a. So I want you to think about that, all right? So in this lesson, when we had negative x, we simply plugged in whatever it was in here into the x. So when we had negative x, we plugged in negative x right here. So if we have 2a, all you have to do is plug in 2a where the x is. So if x is 2a, then x is 2a. So this one becomes a 4 plus 5 2a squared, okay? So if you expand this one out, then what you get is 4 plus 5 times by 2 squared is 4, a squared is a squared. So this is a 4 plus 20a squared. So the answer is 4 plus 20a squared. So that's the answer there. Okay? Now we're going to try question 2 now. So this might be a bit tricky. So the range of the function f such that, so this is the domain, I'm going to explain that in a minute. The domain maps onto real numbers, so that's the codomain that includes the range. And the function is defined as 7 minus x. So what is the range for this one? Okay, see, this one doesn't tell you the range. This one is a domain though. So I'm going to explain this square bracket. So this -3, infinity, this is the same thing as, this is equivalent to, I'm going to write it here, x is between infinity and -3. So you have to know that this -3, next to it you have a square bracket, right? So square bracket means inclusive, and this round bracket means exclusive. It doesn't include the infinity. So you can never include the infinity, so that's why we use this one. Okay, so I hope that's clear to you. So it means x value can be between -3 and 5. Oh, hold on. Why did I do infinity? This is 5 here. So this is 5. That means this is 5 as well. Sorry about that, guys. So it doesn't include 5, but it includes -3. Okay, so x value can be anything in between those two. So I'm going to actually draw this one without any restriction like this one here. So f of x equals to 7 minus x. So y equals to 7 minus x. But this is the same as y is equal to minus x plus 7, isn't it? So this one has the y-intercept of 7. So 7 somewhere there. And it's got a gradient of negative, so you just have to go downward. Okay, so instead of starting from here, instead of going up, because the gradient is negative, you have to go down. Okay, so just have to draw sort of line that goes through that point downward. And because the gradient is negative, we go down, and we can figure out this point right here simply by letting y equal 0. So if you let y equal 0, negative x plus 7, then you get x is equal to 7, which means this value right here is 7 as well. So this is the graph that we get when we draw this one without any restriction. But now look at this question 2. It says that the domain is restricted to -3 to 5. This one right here currently is stretching from negative infinity to infinity. But we have to restrict the domain from -3 to 5. So I think sort of a -3 is somewhere here. -3. And 5 is somewhere very close to 7, so that's 5. So if we restrict the domain, then we are not allowed to have all these other lines. So we need to get rid of this. And we need to get rid of that because of domain. So that's going to be the shape of this function according when it's defined like this. Okay. And now the question is, what is the range when the domain is like that? But now I want you to look very carefully. It doesn't include 5, but it includes -3. So I placed a so what we do is we place a filled in circle there, and for 5 we put an empty circle. We put a hollow circle there. Okay, so it means that it doesn't include 5, it includes -3. Okay. Now the range obviously is from here, that corresponds to this point, and to here. Is that right? So that's the range from here to here. So that should be the answer along here. Okay. So let's figure out this point and this point. Okay. So the equation is that's the equation. Now when x is equal to 5, then you get 7 minus 5, which is 2. So you get 2 right here. Okay. And when x is equal to -3, so it's 7 minus -3, that's equal to 10. So this value right here is 10, isn't it? So the range is from 2 to 10. So I want you to actually write down your answer for the range, okay, using your keyboard on our chat room, okay? Using this notation, this round bracket or square bracket, okay? So this is something that we didn't cover before, but now we have. So wait for your responses. You can take your time. So what is the range? If you want, you can write y like, something like that if you want, or you can use some round bracket combination of this or this with a number in between there. You can use 2 round brackets or 2 square brackets like this. Okay, just give it a go. Anyone? No one's typing. Okay. Oh, Chris has answered 2 to 10, including 2 and excluding 10. All right, nearly. That's nearly. So it's actually excluding 2. We can see that that's not including 2, but this is including 10, right? So the answer is, so domain was like this, but the range that corresponds to it is 2 to 10, but it includes 10 and doesn't include 2. Do you see that? So the answer is 2 to 10, but it's like this. Includes includes 10. Okay, so it's actually, you know, this, so square bracket and round bracket are swapped around. Okay, now let's talk about question 3 here. So this is now the domain. This is the function, quadratic. Okay, so we're going to try that now. Let's get rid of this one. Let's get rid of all of this. So I want you to think about that for a minute. Okay. So this one is x squared plus 6, okay? So that one here, we talked about this. It's x squared moving up by 6. So that's like that. So that's 6 right here. So that's usually what it looks like. But the domain is from -1 to 6. So it's -1. So -1. Maybe I should draw this more wider. Okay. Maybe I should draw this wider. Give me a minute. So I draw a bit wider. Like that. So this is a y equals to x squared plus 6. And this has moved up. So this point right there is 6. And it is going from -1 to 6. So the x value is -1. And the y value is, so it's a bit further away, is 6. But it includes -1. It doesn't include 6. So let's plug in -1 in here. So -1 in there, you get -1 squared, which is 1, plus 6, which is equal to 7. So we get this point right there, and that's 7. And we have to put, because it's including -1, we have to put a square bracket right there. And we have to just get rid of all this part here. Okay. Now when we plug in 6 into this equation right here, so 6 squared is 36, 36 plus 6 is 42. So what you get is that point there, and that's 42. But it doesn't include 6, so we have to actually put a hollow circle there. So let's get rid of that. Let's get rid of that and plug in, put in a hollow circle there. So that's actually the graph at the moment. So I want you to think about now the range. Okay, I want you to think about the range for this one. Okay, I want you to type your answer on the chat box. It's not that difficult. You have to just train your mind in this area, okay, for long enough. Then anyone can do it. Lizzie, would you be able to figure out the range for this one? Not really? Just by looking at this graph right here. Okay, so you want from 7 to 42. Okay, so Lizzie's answer is 7, including 7, and 42 exclusive. All right, so I got some other responses. So Chris is saying 42, but you know, 42 has to be higher than 7, isn't it? Yeah, so Chris has got a very similar answer. Chris wrote 42 and 7 and inclusive. However, the answer is actually 6 to 42. Okay? So the range doesn't actually correspond to the smallest x value and the largest x value. you actually need to know the whole graph and see, oh, it actually starts from 6 right there. So it actually starts from 6 and ends in 42. And it doesn't include 42, and it includes 6, right? So that's the answer for this one right here. So you actually need to know how to graph this one. Okay? Now we're gonna try 4 now. We're gonna try 4. So you get the recording of this later. So I can just erase this. I'm gonna try 4. So this one is, I want you to consider this circle. So y squared equals to 25. I mentioned to you that x squared plus y squared equals to r squared. That's equal to a circle with a radius of r. True? So this 25 is equal to 5 squared. So this one here is simply graph of a circle with radius of 5, situated at the center 0, 0. So this is 5 minus 5, 5 minus 5. I want you to look at this one. This is not so difficult compared to this one. It's just the x minus 6, okay? And everything else is the same. So this is, I can tell you right now, this is simply moving to the right or left or up or down by 6. Okay? The obvious answer is, of course, it's going to the right by 6. If it's minus 6, it's going to the right by 6. Okay? So I can draw this really easily. So it has gone to the right 1, 2, 3, 4, 5, 6, and it's got a radius of a 5. So 1, 2, 3, 4, 5. So that's going to be the edge of the circle, and the circle is going to go kind of get like this. And this is the center. Okay, like that. So that's the shape of this relation. This is not a function, okay? So obviously the domain is from here to here. Okay, domain is from here to here. Range is from here to here. So I want you to pick your answer from here. Okay, so they're just looking for the range. Okay, so I want you to pick your answer. Oh, Chris already mentioned -5 to 5. Excellent, very good. So the answer is A. Okay, so range is from -5. So you can see that this is -5, and this is 5, isn't it? And this is what's the domain though? I want you to think about the domain. Is domain in here in the choice? Yeah, well done, Chris. So I think Chris is doing really well. So the answer is 1 to 7. That's the domain. So this is 1. Well, actually, hold on. Maybe not 7, because the radius is 5. This is 6 right here, isn't it? So the answer is actually, if you go 5 from here, it's actually 11. I thought this was the answer, but this has to be actually 11. Then that would be the answer for the domain. Okay, but this one right here, it shouldn't be too hard to understand, you know? If I draw a number line for this one, if I draw a number line like this is -infinity to -6. So that's, if I can draw, so that's all -infinity to this point right here is -6, and it doesn't include that point. Union, this means union. 6 to infinity, so 6 is right here, and it doesn't include that, and goes all the way to infinity. So you can represent the domain and range on a number line like that. So you have the axis colored as black, and the corresponding domain or range. So this is actually x, so it must be the domain then. You can have another line. If this is range, you can have a line like this and have that as y. Then this will be the range. This is domain. So you can represent your domain and range like this. You can color it like this. Some people do it this way. We put a hollow circle and -6. Pull a hollow circle and 6 there. And yeah, you go up and go to the right, go up and to the left. That just represents this one right here. So so some people color it like this. It means all the values that are below -6, or all the values that are greater than 6. Okay, so there are different ways of representing the range of values on the number system. Okay, so we're going to move on to the next question. So we did up to question 4. I'm going to try question 5 onward. 5 onward. Second. Okay, paste right here. Okay. Now let's have a look at this one. Question 5. Maximal domain of the function of this one. Okay. So this one is a bit difficult to understand because it says maximal domain. So there is something called implied domain. So I have to introduce a little bit of concept. Implied domain or maximal domain. So this is used when if domain is not mentioned, then you take the largest or maximal domain that is possible on a given function. So if I tell you, okay, function f of x is equal to x squared, and I didn't mention anything about the domain, then what you have to do is take the largest possible domain. And that is -infinity to infinity. Okay? Just take the largest possible value. If I give you a function f of x is equal to root of x, the largest possible domain for this one is including 0 to infinity. All the positive numbers including 0. Okay, so you can never plug in negative value there, right? If I give you f of x is equal to a hyperbola, 1 on x, the largest possible domain for this one is any value of x. So x value can be anything except what? Except 0, because you can never divide anything by 0. Denominator should never be 0. So we can write this as all real number except 0, like this. Okay? Or you can write -infinity to 0, and it cannot include 0, union 0 to infinity. So if I represent that on a number line, it looks like this. So that's 0, that point right there. And we just use different color. So it's that, hold on, it's all of that, but not including 0 and all of that. So that's all real number except 0. So you can represent your domain like that. So that's what implied domain or maximal domain is. So if you look at this question, you have this function, and what is the largest possible domain that you can take with this one? Okay, the answer is very simple. We know that inside of the roots of whatever is in there, that whatever has to be positive or equal to 0. Is that right? So whatever is inside the root must be greater than or equal to 0. So we can simply find the domain by solving this inequality. So 3x minus 11 is the bit that's inside of the root, and that has to be greater equal to 0. And from this, you can find 3x is greater equal to 11, and you can divide by 3. So x is greater equal to 11 over 3. Okay? Therefore, this is somewhere in here. Okay? So x is, I'm going to write this one on a number line. So this is the number line with x, and there is a point somewhere. This is about 3 point something, 3.4, I don't know. So there is a point, and it's actually, so and maybe 0 is right there, and 11 on 3 is somewhere here, 11 over 3, and it is including that point and has to be greater than that. So I can represent that as, I can just color that like this, so that all of these numbers greater than 11.11 over 3 represents the maximal domain of this function. So the answer is, it's actually in here. I want you to pick your choice. Okay? So I'll give you 30 seconds for it. The answer is obviously E, right? So if you got that answer, well done. So it's from 11 on 3 inclusive and extends to infinity. So that is the domain of this function right here. Now let's try question 6. Okay, so it might be a bit difficult as well, but we can try. Okay, so I can actually, I'll just take this screenshot of this one and move it to the bottom. Oops, where is it? Where'd it go? Okay. So this one here says the f, this is the domain, maps onto codomain all real number, and this is the equation like this, and what is the range? Okay. First of all, we'll try to plot this one first. Okay, so let's plot y is equal to root of x. So that one is like this. And if you watched my previous lectures, you will know how do you draw y is equal to root x plus 9. So x has been now replaced by x plus 9. That means it's moving to the left by 9. So it'll arrive there. So this is negative 9. And this multiply by 2 is a dilation, so it just makes it a bit taller. Okay, so it will kind of go, so if you apply this 2, it's going to make it a bit taller like that, because it's multiplied by 2. And then plus 4 at the end, that's going to move everything up by 4. Okay, so this 4 right here will make this one go like this. Okay, so this is the y-axis, x-axis, and this point right there is negative 9 up 4. Okay, so that point is negative 9, 4. Okay, so that's the graph of this one. So you should know that any graph, okay, so if we just go back to all these graphs before, so we learned about this 1 on s, basic function, and this one here, which is just the basic form of the circle, and you got this one here. But you know, when you see some complicated things like this, it's all just transformation of the original function. So it's either moving up or down, or to the right or left, or dilation. So it's all really easy if you simply know the shape of these basic functions, and if you know how to move them from to the right or left or up or down. Okay, So that you can see that's really easy, no? Just move to the left by 9, a bit taller, and move up by 4. So it's like this. And you can even figure out that point right there. So I can actually redraw this. So it's like that. So this is -9, this is 4, and this point is y-intercept, so you can actually plug in x equals 0 right there. Then you get root of 9, which is 3. 3 times 2 is 6. 6 plus 4 is 10. So that value there is 10. Now what it says here is that the domain is now from -5 to 0. So -5 is somewhere there, -5. Right here. And 0, that's 0. So we just want our graph from there to there. So that red bit. But it should not include -5. Okay, that should be an empty circle, a hollow circle. So it should be like this. Okay, so the range must be just from here to here. So, okay, so in this case, because there's no like a bouncing from going from, you know, it's very different from the previous one. Which one was that? There was an example. Maybe I rubbed it off. Yeah. So it's not going. It's just going up continuously. So if you simply plug in -5 in here and 0 in here, then you can figure out those points. So let's plug in -5 in there. So if you plug in -5 in there, you get 9 minus 5, which is 4, and root of 4 is 2. So 2 times 2 is 4. 4 plus 4 is 8. So that value there is 8. And we already found that point. That's 10. So the range is 8 to 10. So it's 8 to 10, not including 8, but including 10. So that's the answer. Okay. Now we're going to try another question. So we try this one. This one is a parabola, but it says the domain is all real number. So -infinity to infinity. So let's try this one. On this, just going to try here. So we have, maybe I can move it to the left a little bit just to have some space. So this is moving to the right by 2. You can see x is replaced by x minus 2, so it's moving to the right by 2, and then moving up by 5. So this is 2, 5. So it's 2, 5. So right there, there's the vertex. And obviously the parabola should look like this. And it's all real number. So we're not restricting, we're not cutting this off. Okay, so this one goes up to infinity and infinity there. Okay, so what is the range for this one? I want you to think about this. I want you to type your answer. I'll wait for your responses. So Chris, did you say D just now? Okay. D. So let's have a look. Well, where was D? So D is equal to this one right here. Is that really the answer? Because it went up by 5. Okay, let's have a look. So we know that it's to the right by 2 and up by 5. So this is equal to 5 right there. And this is 5 onward, isn't it? So therefore, that's right. So it's actually 5 to infinity, including 5. That's right. Okay. So number 8. We're going to move on to number 8. Any question, anyone, so far? If you have any question, you can just interrupt anytime. Question 8. F of x is equal to this. So this is still a parabola. And as you can see, this is x is the parabola has moved to the left by 2. dilated by 5, so it's a bit taller, and then it's moved up by 7. But you know, we just have to, in this case, is just f of -1, so we have to just plug in -1 right in here. So -1 right there. So -1 plus 2 is 1. 1 squared is 1. So just 5 times by 1, which is 5. 5 plus 7 is 12. So that's just a baby question. And I'm going to try this one here as well, a plus b. So f of x is equal to this. What's f of a plus b? So when you have f of whatever, that whole thing replaces the x. Okay? So this is equal to just -3. So that's -3 right there. And it replaces the x, a plus b, but always put a bracket, squared minus 2. Okay? So we can expand this one out. -3, and a plus b squared is a squared plus 2ab plus b squared, and there's a -2. So if we expand this one out, this is equal to -3a squared minus 6ab minus 3b squared minus 2. Okay, so what's the answer? So it's -3a squared minus 6ab minus 3b squared minus 2. So this is the answer. So the answer is D. So that's really easy. So when I move on to how much time do we have? We still have like 30 minutes. So we're just going to keep going with all these questions. Right, we're going to try 10. So that's a bit more difficult. And then it's now piecewise function. Just keep doing domain and range. Domain and range. Yeah, so we're just going to keep going with this one. So question 10 is a bit hard, so I want you to pay close attention to this one. Question 10, copy and paste. I'm going to get a new file. Okay. Just place it right there. So you got f of x, root of 49 minus x squared. What is the maximal domain? So we have one goal. Okay, when you have a root of something, you can, no matter what's inside of the root has to be always positive. So 49 minus x squared has to be greater or equal to 0. So we have to solve this one. Okay, so this is a quadratic inequality. So if you have something like 49 minus x is greater or equal to 0, so this is a linear, and all you have to do is simply move this guy to the left, and you get 49 and is greater or equal to x. So that means on a number line, we get, that's a 49, and anything that's less than or equal to 49, that's fine. So that means our domain is like this. So we can also represent this one as 49, that's the highest, and negative infinity. So that should be our domain for this one. But we're not dealing with that simple case anymore. We have a quadratic inequality. So I'm going to teach you how you can deal with quadratic inequality. So this is very, very important topic, okay? Quadratic inequality. So you might be feeling a bit tired now because it's been about an hour and a half, but I want you to pay very close attention to quadratic inequality because it's a tremendously important topic. So if you want to solve quadratic inequality, you first need to draw the parabola. Number 2, you have to highlight, then you can get the answer. So step 1, you have to draw the parabola. So y equals to 49 minus x squared. So this is very, very simple. So there are two ways of doing it. You can either factorize. So this one is 49. So you see that a squared minus b squared is equal to a plus b, a minus b, right? So this is 7 squared minus x squared. So this is 7 minus x and 7 plus x. So you get a quadratic. So this is x and this is a y, and x must be -7 and x must be 7, like this. And this is an upside down parabola like this. So that's how you draw. Another way of doing this is you start with y is equal to x squared, but put a minus sign there, then you get an upside down parabola, you see? So that's what -x squared is. But it's a plus 49 on the outside, not inside. So that has to shift the graph upward by 49. Okay, so that's going to be 49. So the graph is going to be like this. Okay, but you still have to find this point and this point. Okay, and obviously that's 7 and -7. So this way is a lot better. Now once you have that, so I'm going to draw this again. So it's like this. This is 7. This is -7. Okay. You don't really have to draw the y-axis when you do the quadratic inequality. So we have to pay attention to this one. So that is this bit, but it has to be greater equal to 0. So that corresponds to, so this parabola is greater than 0 right there. Okay, from here to here. So it's actually less than 0 here, right? So the answer is, in order for 49 minus x squared to be greater or equal to 0, x must be between 7 and -7. Okay, so that is the answer to this question right here. So have a look. So the domain is -7 to 7. So if I plug in, for example, let's say choose 3. So 3 is inside of this, right? So if I plug in 3 here, that's a 49 minus 3 squared, which is 49 minus 9, which is 40. So root of 40, that's fine. Well, let me choose like something that's outside of this one here. So maybe 8. So if I plug in 8 here, what happens is you get 49 minus 8 squared, which is equal to 64. What's 49 minus 64? That's negative. So it's not allowed, you know? You root of negative. You get math error if you put it into calculator. What if I plug in like -8? So -8 is also outside of the domain. So if I plug in -8 in here, -8 squared is positive 64. So you still get 49 minus 64. This negative sign is separate from, you get 49 minus -8 squared. So you get 49 minus 64. So that's not allowed. So the only allowed maximal domain, the values of x, is between -7 to 7. So that's the answer. Okay. You can ask any question if you want, if anything is confusing here. So let's do maybe another quadratic inequality. Okay. If you have 49 minus x squared is less than 0, then you still draw this parabola like this one, same thing. But this is a less than 0 now, so I'm going to actually do it in different color. So it's actually less than 0. 49 minus x squared is less than 0. Less than 0 here and here. Then your answer for this one, so the idea is you draw the parabola, you highlight the sections that correspond to the inequality, and then you can find the answer. Okay, so this is 49 minus x squared is less than 0. That corresponds to this branch here and this branch here. So that's x has to be greater than 7, you see? X has to be greater than 7 in order for this curve to be less than 0. So x has to be greater than 7, but not including the 7. This is not right, okay? And x has to be less than -7. Okay, and you have to put or in between. Okay, so this or this. You shouldn't put and. So and is totally different. Okay, so this is wrong. Okay. The reason is, can some value be greater than 7 and less than -7 at the same time? Let me repeat that, okay? Can x be greater than 7 and less than -7 at the same time? The answer is no. So that's why you should never use the word and, okay? Because there's no, you cannot be here and here at the same time. So that's why we use the word or. So that's very important, okay? So that's how you do a quadratic inequality. So this involves a quadratic inequality. Okay, I'll be moving. Yeah, let's try next problem. Now we have to do this one, 11. Okay. Okay. So it says for the function of the, f of x, which is defined piecewisely, so that when x is greater or equal to 4, that when x is less than 4. The value of this when a is a negative real number. So a is a negative real number. So it's very simple. You don't have to graph this one. All you have to do is make a choice. Do I have to use this one? So I'm going to give you some question, okay? So is f over a plus 4, is that using this one? If you use that one, then it'll be, you plug in a plus 4 into the square and then plus 3, right? Or is it going to be, is f over a plus 4, is that equal to, by using the bottom equation, a plus 4 plus 4. Is it going to be this or this? If I use this one here, then it'll be, if I expand this one out, it's a squared plus 8a plus 16 plus 3. This one would be negative a, negative 4 plus 4. So it's a negative a, negative 4 plus 4. So this and this cancels out. You just get negative a. So the answer is the answer a, or is the answer 8a? It's actually not here. Maybe I'm going to change that to 19, okay? So is the answer this, because of this one, or is the answer this? You have to make a choice. So I want you to think about that for a minute. The first one or the second one? The key idea is right here. Yeah, I want you to think about it. Write your answers. Okay. So Chris is saying B. Let's have a look. It says that A is a negative real number. So if A is a negative number plus 4 must be less than 4. For example, if A is equal to -1, so let's say A is equal to -1, then this number here will be -1 plus 4, which is going to be 3. But 3, see, when x is less than 4, then you got to use this one. When x is greater than 4, then you have to use this one. But a plus 4 is actually less than 4, not greater than 4. Okay? Because a is a negative number. So you have to use this one instead of this one. So that's why we use this one, and we get the answer as negative a. So the answer is B. So I think Chris is doing really well today. Now we're going to move on to next question. You know, maybe try, yeah, this one here. Just keep going with this. Okay. Now we got a function. So domain is from A to B, and this is the function. And A is less than B, of course, because it's A to B. What's the range? Okay. So we got this function right here. Let's draw this one. So this is very, very simple. So the y-intercept is 11 here, and it's going down because it's the straight line, it's the gradient of -1. And if you find the x-intercept as well, it'll be 11 as well. Okay, because if you let this y equal to 0, then you can figure out x to be 11. And whatever this is, let's suppose that like a is somewhere here, and let's suppose that like b is somewhere here. So we don't really know where a and b are because they're not defined. But we can figure out this value here, and we can figure out this value here. So if we plug in b here, then you get 11 minus b. So this value here will be 11 minus b. But because it includes b, this is a filled in circle. And it doesn't include a, so it must be an empty circle there. And if we plug in a there, it'll be 11 minus a. Is that right? So now the new function would be just get rid of all of this. Get rid of that as well. And it'll be like this. Just from there to there, but this doesn't include that point, okay? So the range for this one is from here to here. Okay, so it's 11 minus b is a lower value, 11 minus b, and then it'll be to 11 minus a, but it includes that point like this, and it doesn't include that point there. So that's the answer. So you can see that this one swapped. This was a round bracket, square bracket. And this is square bracket, round bracket. Okay, so the answer is E, that one there. Move on to the next question. Okay, we can try this just on this screen right here. The rule for the image of the graph, f of x. After translation of 2 units in the negative direction of the x-axis is. So I want you to type your answer, A, B, C, D, E. I think it's really simple. It's just moving to the left by 2. It's moving to the left by 2. The answer is E. So, yep, got a few answers. So the answer is E. It's moving to the left by 2. So the x must be replaced by x plus 2. This is moving to the right by 2. This is moving up by 2. This is moving down by 2. And this is a dilation. You multiply by 2. That's a dilation. So the answer is E. We're going to try this one. 14. The image of the point 0.35 after reflection in the y-axis followed by translation of 2 units in the positive direction of y-axis is. So you have 3,5. Let's just draw this. So it's not about any function, it's just about point. Okay? So there is a point, 3,5. Three, 5 is 1, 2, 3, 1, 2, 3, 4, 5, somewhere there. Now this is going through reflection in the y-axis. So that goes over there. And then followed by 2 units in the positive direction of y. So it's going to move up by 2. Okay, so this was 3, 5. But then this is going to be negative 3, 5, right? So very simple. And moves up. So that's going to be negative 3, 7. Negative 3, 7. Okay. This is not a, this is coordinate system, so this is not the domain and range stuff, okay? So it's not inclusive, exclusive stuff. It's just a point. Yep, we'll move on to the next one. So 15. So we're just repeating the same type of question over and over and over so that it sticks to your mind. So at first you might find this difficult, but as you can see, we're going through the same stuff over and over and over again. So let's take a look at this one. So you got the original graph of square root of x. What does that look like? It looks like this, doesn't it? So, and it became that. So, hold on. We got, how come we only have 2 choices? The C, D, haven't copied all of this. I have to copy this one as well. Yeah. Okay, so these are all the choices. So when this becomes this, what's actually going on? Is a dilation of factor of 2 from the y-axis followed by translation of 3 units in the positive direction of x-axis, or is it positive 3 units in the negative direction of x-axis? So one thing that we know for sure is that because x has been replaced by x plus 3, it has to go to the left by 3. So there must be negative direction in the x-axis. So the answer is either B or E. Okay, but it says a dilation of factor of 2 from the x-axis followed by this, or factor of 2 from the y-axis. I think the answer is y-axis. So I'll show you the difference. Okay, so when you have f of ax, this is a dilation in the x-axis. In the x-axis. When you have f of x and an a on the outside, this is dilation in the y-axis. So take a look. So what's the difference? Okay, so if you have a y equals to root of x, which is f of x, what is a f of ax? That's just the root of ax. X is replaced by ax. What is a f of x? That's just a multiplied by f of x, which is root of x. So they're totally different, right? This one and this one. So this one, we say, because it's multiplied on the outside, it's a dilation along the y-axis. And this is a stretch or dilation in the x direction. Okay? So the answer is, I think, E. Now, we can actually try this, you know. If you have f of x is equal to root of x, I'm going to plot root of 2x and also root of 2x, okay? 2 root of x. And here's an interesting thing. If a is greater than 1, so listen very carefully to this one, okay? Get rid of this here. So we already went through this before with other students in maybe lecture 3 or 4. So if a is a positive number greater than 1, this doesn't actually it doesn't actually stretch along the x-axis. It actually compresses. It's actually compression if a is greater than 1. If a is less than 1, between 0, so it's a fraction, then it's actually dilation along the x-axis. This one on the other end, if a is actually greater than 1, then it's actually dilation stretch along the y-axis. And if a is actually between 0 and 1, this is actually compression. So I can show you, okay? So this one right here is actually 2 in the inside. So this must be horizontal, okay? Must be horizontal. This one must be vertical. But because it's 2, because it's greater than 1, it's actually a stretch. So you're actually stretching this one vertically. But because this is 2 on the inside, and because that's greater than 1, it's actually having the opposite effect. It's actually compression along the x-axis. So I'll show you that, okay? So let's go to this graph, and let's type square root of x. So that's like that, right? As expected. And I'm going to draw square root of x, and I'm going to multiply by 2. So you can see, as expected here, so this is 2 times by root of x, so it's a stretch along the y-axis. So you can see that it became a bit, stretched. So that, if you stretch it like, vertically upward like this, then you get this. And I'm going to draw, now, this is going to be compression. So square root of 2x, okay? So in this case, it seems to have like a similar effect, but you should think that this one has been compressed horizontally. So it seems to have the same effect because of the nature of this graph, okay? But because it's so in this case, the horizontal compression and vertical dilation, they have sort of similar effect, okay? I'm going to give you another example maybe. What else is there? Yeah, maybe this one. This is very, very interesting. So this is going to be like coming up in the next lesson. So if you have sine function, this is for maybe term 2. You'll be doing trig. So I have sine function. I'm going to multiply the sine function by 2 on the outside, like this. And what happened was, this became that. So it was stretched vertically, right? So because there's 2 on the outside. But I'm going to have 2 on the inside. So sine of 2x. So have a look at that. So this is a bit, it's longer, but this has been compressed, squeezed. That's how you get this blue curve. Is that right? So that's showing how these two effects differ. 2 on the outside is a stretch vertically, okay, just goes up. But 2 on the inside is actually compressing this function into a more compact area.